titrations, you don't have to write this down or anything, but titrations are, they're a simple experiment, but they're very precise, okay? It requires patience and teamwork. You actually can't do it without somebody. I don't think precisely you could. So when you do yours, I'll do it with you, okay? So the concept of a titration is this. You have, so we say we have our two reactants, reactant 1 plus reactant 2 makes products. Okay? Now, most generally, always titrations are an acid and a base. Okay, so let's say this one was the acid, and this is, oops, I wanted to use the corresponding, so you know what I'm saying? Okay, acid and base. Okay, so the situation is that one of them you know the concentration of, and the other you don't. Let's say we know the concentration of this one. Let's say it's 0.6 moles per liter. Okay, let's just say. But this is the concentration we're trying to figure out. Okay? Now, from stoichiometry, we can see, okay, the only thing that we can compare is moles. But if I know, okay, this is the thing. You can figure out a way to know when this reaction is fully completed, when both of those reactants are fully used up. So there's no, the limiting reagent is all gone. Okay? So as much reaction as can happen, happens. With an acid-base reaction, what types of things can I use to help me know if the reaction happens or not? Or if it's acid or base? What types of things do we use in chemistry? Pardon? pH? What do I know about, what can I measure pH with? Yeah? What kind of mechanism? Yellow question. What kind of tools can I use? Litmus paper, okay, what else? Bromothymol blue, phenolphthalein, all of our indicators, right? pH indicators. So, say like my acid is my limiting reagent, and it gets all used up. What's going to be left over? Well, a very basic solution. Because if my base is in excess, then that's what's going to be left over, right? Or if I add too much, it's going to overshoot, and I'm going to have base. So once I get to that situation where my pH changes, so I see a color change, then I know the reaction's done. So that's kind of the whole idea of the titration, okay, the big picture. Is the whole purpose is to find an unknown concentration. And the way that we do that is we take a very precise volume of base and a very precise volume of acid so that we can get moles for each of them. Okay? So, this experiment is very special to me. I love this experiment. When I did it, okay, and the thing about titrations is that you should do it a minimum of 3 times and have your results within 0.2 millimeters of error. So it's like if your first, volume, and I'll explain in more detail when I tell you more about the experiment. Say your volume that you collect is 0.16 liters, and then the next one is 0.21 liters. You can't count the 0.21. It's too much. You went too far. It has to be very close. So with a titration, they recommend, this is kind of like the standard, is you have to do 3 trials within, I think it's 0.2 no, what is it? Must be is it? 0.2. Yeah. Milliliters. No. Yeah. Difference. Maybe it's 2 milliliters. No, it's 0.2. Okay. So, yeah, it's very fun in the sense of if you like things that require patience, I guess. I don't know. I'm so excited about doing this last year, and they all hated it. So I don't know. So you want to see the picture of me when or do you want to wait till later to see it? Okay, so when the color changes, it's called the end point. What did one titration say to the other? Let's meet at the end point. That's not me. That's chemistry cat. That's me on the right-hand side. Yeah. I was very excited about my titration. So when you see the color change, it's since we use phenolphthalein, it turned pink when it's base to show. But it needs to be a very light pink, not a dark pink, so to make it closer to precision. This is my chemistry teacher, Mr. Baltzer. I still go see him when I go back home, and I call him and say, how do I teach chemistry 30? And he tells me, so that's good. And those are my two friends, Marie and Danielle. We were titration buddies. Okay, so with the titration, you keep adding the base. So if we're doing phenolphthalein, which is what we'll do, you add the base, swirl, and it stays pink, and then you swirl and the pink goes away. This is a good endpoint where it's this like lightly pink. This is too far. Bad results. Can't do that. Wrong. Can't use that result. You can use that one. Okay. Yeah, I had lots of fun cartoons for this one. This is them doing their titration. They went too far and they got mad. One more drop. Oh, it's clear. Add one more. It's turning light pink. Bright pink. Mad. Okay? So that's titrations. So I'll just give you a couple basic notes to start with. And I'll show you the equipment and stuff like that. And yeah, and then we can do less notes tomorrow, and you can start doing your lab soon. This is two like full lesson days of the notes. That's why it's so much bigger.